Hello and welcome to Call of Chemistry. This will be the second video of some basic concepts of chemistry series. In this video, we will discuss about laws of chemical combinations and their application. So let's start. The first law is law of conservation of mass. Suppose A plus B react to give C plus D as products, and suppose these are reactants and these are products, and suppose mass of reactant A is X and mass of reactant B is Y, and they react to give mass of reactant C is P and mass of reactant D is Q. So this law says X plus Y always equal to P plus Q. In other words, summation of mass of reactants will be equal to summation of mass of products. But there is a limitation for this law. We all know that chemical reactions are nothing but bond breaking and bond making process. Hence, either some amount of heat released or absorbed while bond breaking and bond making. Then, all amount of reactants can't combine to give product. Some of them are converted into energy or heat following E is equal to mc square formula. As a result, mass of products will not be the same as of reactants. So, what I am saying that this A and this B combine to give C and D, and in this process some bond is destroyed and some bond is made. In that case, some energy is released or some energy is absorbed in terms of heat. So we know the relation is equal to mc square, where m is the mass and c is the velocity of light, and the mass which is reacted will be converted to this energy, and this energy in terms of heat it is absorbed or released. So the mass of the reactants will not be the same as the mass of the products. Better if the law is modified such as total amount of mass and energy will be equal to before the reaction, so total amount of mass and energy before the reaction will be always equal to total amount of mass and energy after the reaction. This is the modification of that law, where we introduced the energy as well as the mass. Now this is the better. Now the second law is law of definite proportion. This law states a chemical compound always contains exactly the same proportion of elements by mass, and we will understand by an example. So what it tells a chemical compound always contains exactly the same proportion of elements by mass. We will understand by an example. Suppose water is collected from pump and as well as water is collected from lab. So water, one source is collected from pump water and another source is collected from lab. Suppose for pump water, for pump water, X gram of hydrogen combines with Y gram of oxygen, and for lab based water, M gram of hydrogen combines with N gram of oxygen. So according to this law, we can say that X is to Y is equal to M is to N. This is the main thing of this law. But not all cases this law is obeyed. Suppose ethyl alcohol, which is C2H5OH, and dimethyl ether, which is CH3OCH3, both have same molecular formula and that is C2H6O, and both contain same proportion of carbon, hydrogen and oxygen, but we all know they are different compounds with different chemical properties. So how do we say that these are two isomers of this molecular formula? Ethyl alcohol and dimethyl ether are the isomer of C2H6O, and both ethyl alcohol and dimethyl ether contain same proportion of carbon, hydrogen and oxygen, but they are different compounds with different chemical properties. Now, what are the third law says? The third law is law of multiple proportions. If two elements can combine to form more than one compound, the masses of one element that combine with a fixed mass of the other element are in ratio of whole numbers. This is the statement of law of multiple proportions. We will understand by an example. Hydrogen combines with oxygen to form two compounds, namely water and hydrogen peroxide. Now, in water, hydrogen is to oxygen. This remains in 2:16, and for hydrogen peroxide, hydrogen is to oxygen remains 2:32. In both the cases, the amount of hydrogen is fixed, that is 2, and the amount of oxygen which combines with a fixed mass of hydrogen bear a simple ratio, that is 16:32. That is 1:2. This is the explanation of this law. And the fourth law is Gay-Lussac's law of gaseous volume. This law states at same temperature and pressure, when gases combine or are produced or in a reaction, they do so in a simple ratio by volume. We are saying that suppose the formation of ammonia is to be taken as example, then so here see that 3 volume of hydrogen combines with 1 volume of nitrogen to form 2 volume of ammonia. So here nitrogen is to hydrogen is to ammonia bears a simple whole number ratio, which is 1:3:2. In other words, we can say that 100 ml of nitrogen combines with 300 ml of hydrogen to form 200 ml of ammonia. Now the fifth law is Avogadro's law, which is very important. Avogadro's law states at same temperature and pressure, equal volume of all gases contain equal number of molecules. What does it mean? Suppose hydrogen gas and chlorine gas combine to form hydrochloric acid. So here you see that 1 volume of hydrogen combines with 1 volume of chlorine to form 2 volume of hydrochloric acid. So according to this law, equal volume of all gases contain equal number of molecules. So here hydrogen and chlorine gas, the volume of hydrogen and chlorine gas are the same, that is 1 volume. So they contain equal number of molecules. Suppose hydrogen contain n number of molecules and chlorine also contain n molecules. And as hydrochloric acid is formed as 2 volume, so here 2n molecules will be formed. So we can say that 1 molecules of hydrogen combines with 1 molecules of chlorine to form 2 molecules of HCl, or we can say that half molecules of hydrogen combines with half molecules of chlorine to form 1 molecule of HCl. That means it is possible to divide polyatomic molecules into atoms. So by this I am stopping here. If you have any doubt, please let me know in the comment section. Please like, comment and subscribe my channel. Thank you.